Hi, it's Professor Monty. Let's talk about finding the domain of a function algebraically. All right, so the domain is the set of all input variables, often x, for which the function is a real number. So what values can we plug in for x, or whatever the input is, so that we get a real number out, is what the question is. That's going to be our domain. So I've got three examples here. Let's look at this first one, A. It says f of x is defined to be x squared minus 9. Well, there's really two main rules we have to look at. For the function to come out a real number, the denominator can't be 0. If the denominator is 0, we know anytime we divide by 0, it's undefined. The other rule is any value under a square root must be greater than or equal to 0. Okay, you can't have a negative number under a square root. If you do, it's not a real number. So if I have f of x equals x squared minus 9, there's no denominator with a variable in it, so that's not an issue. There's no square root, that's not an issue. So we can actually plug in any value we want to for x. So in this case, the domain is just going to be all real numbers. Oftentimes, we'll just write it as a big block R. Sometimes if we want to go to interval notation, we would say, oh, that's negative infinity to infinity. So it actually depends on not only your teacher, but what chapter of the book you're in. They'll display it different ways. Okay, so here we can use any number we want. Now I've got another function, g of x this time, x minus 5 over x squared minus x minus 12. Well, we don't care about the numerator. If the numerator is 0, that's fine. If it's any other number, that's fine. So we can just ignore the numerator as far as the domain goes. But what we have to do is look at the denominator, because remember, the denominator can never equal 0. So let's set that equal to 0, find out what values does that. So x squared minus x minus 12 equals 0. That factors in x minus 4x plus 3. Well, setting each of those equal to 0, we get x equals 4, or x equals negative 3. I kind of skipped a step right there. Let's go ahead and write that out so we don't skip that. All right, so there's the two values that would make the denominator 0. So the domain isn't those numbers, it's any real number except those. So we could either write it as all real numbers except we'll say negative 3 and 4. Kind of box it that way. Or if we're writing interval notation, it's the set of all real numbers with those out. We'd go, oh, negative infinity to negative 3, take that out. Or, union symbol for or, negative 3 to 4, or 4 to infinity. So if we want interval notation, we go this way. If we want to just list it and say, hey, it's anything except those. Again, it depends on what chapter in the book you're in or how your teacher wants you to display it. I've got another function. This one doesn't have x in it. It's d of t. T is the input variable. So that's where my domain is going to come from. What values of t can I use? Well, remember, values under the square root can't be negative because then it's not a real number. So the values under the square root this time, t plus 2, have to be greater than or equal to 0. So they're not negative. Well, we just subtract 2 here, and we say, oh, t has to be greater than or equal to negative 2. So it's anything. We can either state it that way, it's all real numbers greater than negative 2. Interval notation would be a bracket at negative 2 all the way to infinity. All right, so that's the idea. There's some examples, different types of problems, but the idea of the domain, any value you can use for the input variable, often, again, that's x, but it doesn't have to be. And the two big things to look out for, denominator can't be 0. So any number that makes the denominator 0, throw it out. And if you have a square root, anything under the square root has to be greater than or equal to 0 because it can't be negative. All right, work with these in practice and you'll get it.